All right, so here is an example of a random variable, and I made up this game called Rollin'. And with this example, I'll be able to teach you how to do the expected value, the variance, and the standard deviation for a random variable. So in this game, it costs $10 to play. You're rolling one dice, or one die. If you get a 2, you win $4. If you get a 4, you win 10. If you get a 6, you win 40. And any other rolls, you end up losing money. Actually, these become losers too. I put win in quotations because you really don't win $4. You actually lose $6. So we're going to examine the net winnings to find out if it's a good idea to play this game or not. I mean, the payout seems pretty good, winning $40, but that only happens. It's only a win of $30, and that only happens one-sixth of the time. So what we can do is we can call X the net winnings. That's our random variable, and it is dependent on a random event, which is rolling the dice. So winning $4 is really losing 6, and that happens with a probability of 1/6. If you win $10, it means you broke even. That happens a sixth of the time. Winning 40 is really like winning 30, and that happens a sixth of the time. And then the rest of the time, you end up losing all the money, -10, with a probability of a half. The one formula that I'm teaching this unit is the expected value or the expected mean. It has two nicknames, E of x and also mu sub x. That's the expected mean. Now for regular averages, you add up what you got and divide by how many there are. That's just for numerical averages. For a random variable like this, each of these numbers are weighted differently. This is more important over here because this happens more frequently. The formula is you add together each x times each of its probabilities. So in this example, it would be -6 times 1/6 plus 0 times 1/6, which would be 0, plus 30 times 1/6 plus -10 times 1/2, or 3/6. You work the arithmetic out on this, and you end up getting that the expected value is a $1 loss. So when you play this game, you can expect to lose $1 on average every time you play. Now, we're going to take that value right there for the expected value, and I'm going to roll it into one more formula, and that's the formula for variance. So you don't need anything else now except for that number there. The expected value was -$1. What we're going to calculate now is the variance of a random variable, and its formula also includes a summation. And one version of the formula takes each individual x, subtracts away the expected value squared times the probability of each individual event. So you can't figure out the variance unless you know the expected value. And on this particular example, it would look like this. It was a -$6 for the first x that was on the list. Take away -1 squared times the chance of that happening, which is 1/6. The next one on the list was breaking even. And that happens 1/6 of the time. And we have to subtract away the expected value squared. The next item on the list was winning $30. And that happens 1/6 of the time. And then finally, winning 0 or losing $10 was the other x. And that happens half of the time. Now, typing this in to the calculator can be kind of a chore. You have to type each of these in individually and then add them together. There is a nice trick by using the calculator in order to do this. which can help quite a bit. And I'm going to see if I can actually show you kind of like this what I'm talking about. So what you can do is you can go to the Stat button and hit Enter, and then go to List 1. And under List 1, you can type in all of the x's. So -6, 0, 30, and -10. So like so under List 1. Under List 2, we can type in List 1, take away the expected value. So I'm going to go all the way to the very top of List 2, and I'm going to type in at the very top, List 1, take away -$1. I'll go to the very top and do that. Hit Enter, and you can see that it's already done the subtraction. So far I've got in List 2, I've got all this typed in. Now I want to square that. So I can go to List 3 and go to the very top of List 3 and call it List 2 squared. This is a helpful thing to do when your random variables are very lengthy. There's lots of calculations, so I can do that and hit Enter. And now I've got List 3 of all this information. I want to take List 3 and multiply it to each of the individual probabilities. So I go to List 4, and I can type in one by one the matching probabilities that go along with each of those x's. So I've got List 4 set up. The only thing left to do is take List 3 and multiply it by List 4, and then add those results together. So I can call List 5 List 3 times List 4. And it's not necessary to do it this way, but it certainly makes it maybe a little less error prone, especially when you're dealing with many numbers on your list, which could be, this only has 4 situations. Finally, we got to take List 5, which is all of these individual answers or contributions, and we're just going to add those together, and that can be done pretty easily by pressing Second, and then Stat, and then sliding over to the Math menu and choosing choice 5 on my calculator, which is the sum. Of course, you don't want to do it when you're actually on the list. I made that mistake earlier today too. What you want to do is you want to make sure you're on the home screen before you do that. So again, it's Second, and then Stat, and then to Math, and then Sum. So you're going to add together everything under List 5, and that gives you your variance, $205 squared. So the answer to this question is $205 squared. And that's very clumsy to work with. Variance is always expressed in terms of units squared, and that's pretty clumsy. So because of that, we usually turn the variance into the standard deviation. And the standard deviation is just the square root of the variance. So if I want the standard deviation of this event, it would be the square root of $205 squared. And the square root changes the dollars squared into just dollars, and we end up getting that the standard deviation is roughly $14.32. In In terms of what the standard deviation means, it's a little bit harder to understand that than it is to understand the random variable or the expected value. Expected value means every time we play, we can expect to lose on average $1. The standard deviation is a measure of how spread out the payouts are or the net gains are. If a game has a larger standard deviation, it means that the prizes are more widespread. If it has a smaller standard deviation, it means the prizes are more compact in terms of their value. So standard deviation becomes a little bit more necessary when you're comparing one game to another, but the expected value is something that you definitely would be concerned about if you don't want to get ripped off. All right, well, that's a quick explanation of how to use the calculator to figure these things out, and another example for my students especially on how to calculate the standard deviation and the variance. Again, you do not need to know how to use the lists to figure these things out. It just seems to be a very clean way to work it out. If you wanted to work them out by hand, that would be totally fine too, and you might want to start by just flipping those signs in the middle. And the arithmetic behind it's really not all that nasty. I mean, you get 36 times 1/6. I mean, some of this I can do in my head pretty quickly. It's a 6. This becomes 1 squared, which is 1 times a 6th, which is just a 6th. This is 31 squared times a 6th. That one's one I really can't do really quickly in my head. 31 squared divided by 6. And this one ends up being negative 9 squared, which is 81 times 3 over 6, which would be half of 81, or 40.5. So really, do you really need to use the lists on this? Not necessarily. You could still get your 205 off of this one. And the arithmetic's not that nasty. So there's some options there for you. And good luck. Remember, you can always email me or subscribe to me or write a comment if you have a comment about something you want to see worked out. And I'll take requests if anybody wants to offer up a question that they're having some trouble with. So good luck.